enough about me having my, my pointless trip of nostalgia. So, we were talking about C++. We were talking about how object-oriented programming enables constructing large programs. We were talking about modularization, and we talked about the concept of information hiding. So here is another analogy. I provided a fast food analogy last time. So consider the design of your standard consumer automobile. Generally, cars can be thought of as having a stable interface. All cars have a steering wheel, a brake and a gas pedal, a shift stick, etc. Some means of shifting gears, even if it's to put it in automatic, and you still have to be able to do forward and reverse, right? There was a big controversy recently when they started putting buttons in instead of having to turn a key, because it threw all of the old timers off. But in general, all cars have the same interface, right? Doesn't really matter what the model is, what's under the hood, how many passengers it has. All of these components do roughly the same things to varying degrees of efficiency. This means that if a person can drive one type of car, they can learn to drive other types of cars very quickly. If you've driven multiple different cars in your life, it's like it takes you about maybe 20, 30 seconds to get used to the new car, and then you just kind of intuitively do it. They might have it'll probably take you, the worst is learning how the wipers work, And that's because it's not as standardized as everything else, because it's the bloody wipers. It's an auxiliary feature, and cars didn't even originally have them. Of course, cars didn't originally have windshields, so, The implementation details of the engine are hidden from the user. It doesn't matter what model the spark plugs are, how many cylinders it has, The way that the engine works is inconsequential so long as the interface remains stable. That is, so long as actuating the interface has the desired effect on the car's motion. Actuation is a term that you will come to know and hate or love in mechatronics, because roughly speaking, electronic devices are divided, you have the core things that process things, you have sensors, and you have actuators. Those are the terms, right? If you are a robot, then when you manipulate things, you are actuating them. So, well-designed software works in the same manner. The user should be able to use a stable interface to access your code without having to worry about its implementation details. So, and now for something completely different. Let's talk about member functions. So a member function is not dissimilar from a function, like a function in the C sense. The only difference is that they are now members of classes. So you may or may not remember this from Python, but the way that you access, I don't know, what do they call them in Python?
Methods.
Methods, yeah. Java speak. So when you create an object of a particular class, all of the member functions of that class are accessible from the object itself using dot syntax, right? You call the member function on the object, right? From a syntactic point of view, the same way that variables might be either private or public, member functions can also be either private or public. In this particular case, we have string show void const. So this is basically just give me a string which represents the data that is contained in the class. Because this is a Euclidean point in three-dimensional space, we represent that as a tuple of the three coordinates, right? It's kind of a C++-y way to do it. You first declare string variables and convert. You use the explicit toString conversion method to extract the strings from the underlying data. Note how much easier this is than doing the same operation in C, where you have to specify your format tags, and you have to use like snprintf or something like that, right? Just toString, very easy, very quick. And then, of course, we have string concatenation using an overloaded plus operator in a very similar manner to what you have seen in Python. Yes?
So toString is like an operator in of itself. It's not like recursive. It's not calling the same function just because they're both named string. I've never seen toString, so I'm just a little bit confused at that.
Yeah, it's just a library method that takes anything of any type and produces whatever it thinks the string should be. It's in functionality, it's equivalent to class definitions of the strdunder method in Python.
Okay.
Yeah. What?
What does it mean that the function is like constant?
Do I have that in the slide? Yeah, here we go. The constant attribute allows us to distinguish that the function should have no effect on the state of the class. That is to say, it does not need to modify the member data. So when you declare a member function constant, essentially it's a stateless transaction. Or at least it uses no state outside of the function itself. Kind of locks it out of write permissions for the member variables. This is sometimes a useful restriction. One thing that might be of interest, though, this is a public function, public member function. It's requiring a private data which it has access to. This function works, of course, otherwise it wouldn't be in the slide, right? Although Z is a private variable, private variables are accessible anywhere inside of the class in which they are defined. So, we write when we write a member function, it can validly read the private variables. Now, in this particular case, it has no permission to write to any of the variables, because we have specified it as a constant function. But if that weren't the case, then it would be able to read and write to any of these variables, including private ones. So this is partially also what is meant by the idea of encapsulation. Just because it's private doesn't mean that we can't do anything with it. We can write public methods that provide a fixed way of interacting with the private members. Make sense? So far, so good? Okie dokie. So, in the previous example, the point class has the member function show. Show takes no arguments and returns a string. The output of show is a formatted string which displays all three coordinates. Note that the member function has access to the private member. And we already talked about what const means. So now let's consider a slightly longer example, split over 2 slides. We now have, I'm just kind of leaving show and ellipses since we've already talked about it. Let's introduce 2 additional ones. Set Z and distance 2. So with set Z, we set this arrow Z to setter times 2 minus 1, right? So we're taking some double, which I'm calling the setter, or the value which is being set to Z, right? We are not actually setting Z directly, but rather performing some function on it prior to setting it to the value of Z, or storing that value in the member variable Z, I should say. This is basically to demonstrate that when you have private members and you are accessing them through setting set methods or set functions, you can control the manner in which data gets stored in that variable, right? Now, you might not think this is, it's like, okay, sure, this seems like a somewhat stupid example, right? So let me talk about a slightly less stupid example, shall we say. Let's consider a stack. You all did stacks in the assignment, right? The stacks that you guys did in the assignment, if you wanted to, you could pull values out of the middle of it. You could access stuff in the stack that was, you can read from the middle of the stack, and there's no problem with that, right? This is somewhat unsafe behavior. Normally, if you're going to read from the middle of a stack, you're making an assumption about how many elements are in the stack. That assumption might be wrong. You could be dealing with a stack containing 3 elements, but you expect 10, for example, right? If you're dereferencing an array outside of the bounds of the array that has been declared, unless you're specifically checking for it, that's a problem. And if the programmer just has access to the array, they can make bad decisions about how to interact with it, right? Consider encapsulating a stack inside of a class, right? The array that actually holds the stack values would be set to private, right? Not accessible outside of the class itself. The methods that, the public methods that would be provided would be things like push, pop is empty, right? So you're not supposed to read the data in the middle of a stack. It's a queue, right? You're supposed to read from the queue at the correct position in the queue, right? That's the whole point of maintaining the data structure that way. So, by providing a public pop method, right, you are guaranteeing that whenever information is being pulled out of that stack, it is being pulled from the correct place, right? Thus avoiding a large class of errors that might be caused by people not understanding the data structure or using it correctly. It also allows us to not have to answer various other questions, like, is this stack being stored as an array or a linked list, for example. It's actually more efficient to store a stack as a linked list as an array than as an array, as it turns out. So if you have a stack as a linked list, right? Say this is like the variable, right? If this is the top of the stack as well as the front of the linked list, adding a new element to, like pushing something onto the stack, is a constant time operation, because all you have to do is allocate the new node, redirect the pointers, and that's a constant. You don't have to trace through the data structure, right? I think the arrays that we were using put the new elements at the back of the array, if I'm recalling that from the assignment correctly. So, also, popping from a stack that's a linked list is also a constant time operation, because you don't have to trace through all of the elements of the linked list in order to find the thing at the top of the stack. it's simply the first element, right? All you do, if this is like the variable, or the pointer, right? All you do is redirect the pointer to the next element, take the value, return it, and then delete the node, and that's a constant time operation. You don't have to go through, it's not dependent on the size of the stack, right? So that's a more efficient way of doing a stack, but from the perspective of a class, whether you're using this or you're using arrays, it doesn't matter from the perspective of the interface. Now, it'll matter for runtime, certainly, but in general, functional correctness comes before runtime and efficiency. Make sense? Good. So, in addition, we have a distance to member function, takes another point, which is in this case being called other. We are declaring double, this is technically not necessary, right? But like you could just inline all of this, but because this is a slide and I've only got so much, line width, I've declared a bunch of variables to hold these intermediate values, right? So the dx, or delta x, is this dot x, or this arrow x minus other dot x, comma 2, which is like raises this to the power 2, right? Do that 3 times for x, y, and z, and then return square root of dx plus dy plus dz. Simple application of simple application of Pythagorean theorem to 3-dimensional space, which I think, like you guys have seen this. You've seen 3-dimensional Pythagoras before, hopefully. Good. Okay. So we can then declare 2 points, foo and bar, as usual. We can set foo.x and foo.y directly using dot syntax. We can set z using the set z method, but not otherwise. And we can do the same with bar, and then we can show the contents using show, and we can calculate the distance between them. There we go. Make sense? Quick note on this versus other. The keyword this binds to the object on which the method is called, right? In Python, it would roughly be the same as self dot, right? It's a pointer, so it must be dereferenced and combined with dot syntax. That's why it's an arrow. Make sense? Good. You'll notice that we don't always do that. That's just to demonstrate that if you need a pointer to the object on which the function is being called, it's called this by default. Make sense? Any questions so far? Yes?
Wait, so is this the pointer or is this the dereference pointer?
It's the pointer. You have to dereference it to get at the data, which is why we're using the arrow, which if you'll recall from structs, is how you get, that's how you get information out of a struct if you have a pointer to one. Make sense?
Okay, and how does that compare to not using a this and just using z?
It does the same damn thing. It's a synonym. Sometimes it will be useful for you to pass, in theory, right? Sometimes you'll want an object to return a reference to itself, right? This is a reference to itself. So, it's kind of like one of these more minor syntactic points that I just wanted to throw in the slides because like I want you to see it, you know. But yeah, because I don't know to what degree in the algorithms course they're going to be using that type of thing. So yeah. Any other questions? Yeah.
This one's not related to the content, but are we going to be doing any C++ coding for the exam, or is this like purely for our knowledge?
This is for knowledge. You'll need it next semester. I promised the professor next semester that I would do some C++ with you before I let you go, and you know, so we're doing it. So, good. The principle of encapsulation states that data to which access is controlled should be bundled with the code that accesses it. That is to say, if you have an application where data requires certain functions to be performed over that data, they should be put in a class together, right? Going back to the stack example, you wouldn't have the data storage of the stack in a different class than the methods which access the stack. It doesn't make any sense. You put them together, right? In this sense, encapsulation implements information hiding. Z may only be accessed via set Z, so we may enforce any data policy that we wish. This example is somewhat facile, but imagine a scenario where an improper value may lead to a zero division error, right? So, you know, imagine you're keeping a variable, and if that variable is set to the wrong value, you end up with a zero division error, right? Which will still crash a C++ program, of course. If you want to put a check in to make sure that it's not going to cause that error, you can put that inside of a setting method. But if you allow the user direct access to the variable, you cannot protect against that form of error. Make sense? Hopefully. By encapsulating the variable that could cause the error, we can enforce a policy where values that may cause unstable results are stopped before reaching the member variables. Member functions of this kind are called mutator methods or getters and setters. So we've talked about setters primarily, but you can have the same thing going out, right? It's possible, it's conceivable, that the data that's stored inside of your class may not be fit for human consumption, right? It might be stored in some kind of intermediate format that doesn't mean anything to anybody who's not the class. Therefore, you can write a get method which performs some additional calculation mutation in order to give the information in a more useful fashion to the next stage in the process. Make sense? Hopefully. So, consider the distance to member function. The purpose of this function is to calculate the Euclidean distance between 2 point objects. Somewhat similarly to Python, the function takes a reference to another point object, though in this case it is explicitly typed as such. So this is what it looks like in snake language, right? The same method. I'm just gonna, yeah. I'm just gonna put some math in here because I don't even care anymore. Right? So note, remember that in Python, the first argument of all methods is a reference to the object on which the method is being called. In C++, it is assumed that you will want to reference the object that the method is being called on, and that you don't have to put that there explicitly. So in terms of C++, the arguments list starts here, right? Make sense? Because like, what the heck even is the purpose of that anyway, you know? I'm sure Python has a very Python reason for doing things that way. But as you all know, I have declared holy war on Python, so even if they have a reason, it's stupid. So yeah. Oh, also, in Python, it's assumed that other is going to be another object of like point class, if you had a point class in Python, just because that's the way that it's being used here, right? In Python, any class that has an X and a Y field would run through this with no issue, regardless as to what X and Y meant locally in that context, right? Whereas in C++, which is a good language, the argument is constrained to be a point, right? If this function is called with a argument of anything other than another point class, that's an error, my friend, and it is correct for that to be an error. If you want the ability to put anything you like in here, you can just do multiple methods that take multiple different types of inputs using overload. You can just do things correctly. Wow. You can tell it's been a week because I can't even get properly mad at Python today. Anyway. So, within the body of the function, the variables of other are accessed as normal. By contrast, the class accesses its own members with this arrow. Remember C. This operator is pointer dereferencing combined with member access. Each class implicitly carries a pointer to itself called this, which it uses to access its member variables. Again, you can just use the numbers, right? Or, sorry, you can just use the identifiers as well, but it's important to know that this exists, right? So that's why we're talking about it. So, there we go. Okay, so now let's talk about constructors, all right? In object-oriented programming, you have two very, very important types of member functions or methods, known as constructors and destructors. Destructors are not used quite so much. We're going to talk about constructors here. So, the constructor is run when the object is created. Upon instantiation, this is what is run. This particular one, shall we say, the syntax is a little bit weird because, like, you know how, okay, equivalent snake language again. This is how you do this. This is what a constructor looks like in snake language. Def, init, under method, self, x naught, y naught, z naught, and then you would do like self dot x equals x naught, self dot y equals y naught, Y naught, right? Z naught, something like that. You can also put this kind of thing outside of the constructor in Python, but this is how initialization during construction works in Python, right? In C++, they're just like, yeah, you know what, you probably just want to create these, variables with this name, so we're just going to use them like they're functions, and we'll simplify the syntax slightly so that you don't have to do all of that just to initialize your dang variables doing nothing to them, right? Make sense? If you want any additional functionality to be performed, then you put that inside of the square braces. Like if there's some other method that needs to be called to initialize communication with something or something like that, that's where you would put it. Make sense? So far so good? Yeesh. Good. So, encapsulation can also be applied to the creation of objects from classes. You can create a constructor by creating a member function with the same name as the class. This is reasonably this property is reasonably well distributed through object-oriented programming. In fact, if you have a function that has the same name as the class itself, normally that's a constructor. I know it works the same way in Java. You can create, yes. Rather than manually assigning each of the public member variables and then using whatever setters are available to call to initialize our object, we can now do it in one function call. We can also control deallocation using destructor method functions. This is of particular importance if member variables need to be freed or file streams closed or anything of that nature. So remember that C++ is built on C, which means that you have malloc and realloc and all of those lovely things that are possible to do, which means that you might have pointers that need to be freed when you're destroying objects of classes, right? So the code which destroys should be put in the destructor. Make sense? Good. Also, like if your class keeps like an active file stream open the entire time that it's open, which I don't recommend, but maybe you have a reason to do that. You would also want to be closing off your file stream in the destructor. Make sense? So, in addition, the above example uses default arguments. These work pretty much the same as in Python. They probably didn't tell you about default methods or default arguments in Python, did they?
They did.
They did?
I think so.
Okay, cool. Well, they work the same in C++, basically. If you put an equal sign here and then a literal or a value of some sort, if that argument is not provided, it will default to the value that has been provided by the equal sign. So, for example, when we are declaring an object, a point object called bar, note we are providing only two arguments. The third still exists and is given the value 0. Make sense? Good. The assignment of 0 to each member variable within the argument declaration itself says to the compiler, if no argument is provided, use this as the default value. This allows the user the option of whether they want to provide an argument or not. In this example, we use this to set default initial values for the member variables of our class, but you can do this with any C++ function. They all do it. But you can't in C. So there you go. So, good. Line 3 in the above declaration gives an initialization list. Line 3, initialization list. Use of an initialization list is not mandatory, but some types of member data can only be initialized this way. It is a comma-separated list of data members, which appear to be called like functions. The arguments are the values you wish to initialize the data members with. the initialization list must be separated from the rest of the function declaration with the colon symbol and must occur before the opening curly brace. These initializations are performed prior to the execution of the body of the function. They are done by default up front. It's, quick, fast, easy syntax for initializing all the variables you want to create. Make sense? Any questions? Cool. So we're going to talk a little bit about why any of this, right? What are the applications? In this section, we are going to look at a C++ class implementing a gradebook for use in an academic setting. We are going to look at how an organization might go about producing such software. When putting software together, there are a number of people that can be involved, but we are going to focus on the following. We have back-end developers, front-end developers, and clients or end users, right? This is, you may recognize these terms from, just this gigantic, heaving, pulsating mass that is web development. Web development has become extremely complicated in the last 10, 15 years. I remember when I went to school, we used to make fun of web developers. We used to say, that's not even programming. It's not even programming anymore. That's not true. History has proven that particular prejudice to be wrong. Although back in the day when all you were really doing was HTML with a very tiny amount of JavaScript, then yes, that's barely programming. But apparently HTML can be made Turing complete. So, it just turned 10:20. All right.
Clock is off, I think.
Oh, is the clock off?
It says 10:17 on your computer.
Are you telling me I've been stopping class 3 minutes early and nobody's told me for how many months now?
For some
That
reason,
clock
up
changes.
until today, they always line up at some point.
Yeah.
And it always lines up before the class ends. So today didn't. So.
It really is true what they say, a broken clock is right twice a day, right? Even if they're moving at different speeds. Anyway, so let's talk about the people involved in software projects. Let's start with the most important one, the end user. The customer is always right. In many ways, the end user is the most important person in the development of a piece of software. The end user is the customer of the product that is the software. If the end user is not satisfied with the performance of the product, they or their organization may switch to a competitor's product. Needless to say, this would be a bad thing for your hypothetical company. The software industry is an odd duck because the product they sell has hypothetically infinite supply. The laws of supply and demand do not dictate price, right? If you think about, anybody do microecon in this room? Yeah, so
Worst friend I've ever taken.
it's okay, so long as you learn what supply and demand is, then you've got everything you need out of that course, right? So, if you recall from economics, you have a supply curve and a demand curve. The more that's demanded, the less supply there is. Sorry, this is the demand, that's the supply. The price of the product should be the intersection of the demand and the supply, right? Right there. Problem. In software, because software is infinitely duplicatable, in theory at least, your supply is always infinite. Always infinite. So, supply and demand is not what dictates price, right? Because obviously, if it were the case that supply is always infinite and supply was dictating the price, then the price of all software would be zero, right? Which that's actually kind of the direction that video games, particularly like on Steam and the App Store, have actually been going. But come on, there is like an almost infinite supply of, you know, sort of midweight development, you know what I'm saying? Like kind of like mid-tier indie games. There's like just like literally an infinite number of them. But anyway. Factors such as program applicability, reliability, convenience, and customer support dictate price rather than product scarcity. Okay. Thank you very much, everybody. We'll see you on Monday.
Good question.